Now, what we want to do here is flip the bouncing enemy's velocity depending where it's trying to leave the game. So for example, if they try to leave the game from the left bound, then we want its horizontal velocity to move to the right. If they try to leave from the right, we're going to change the velocity to move to the left. And we do the same thing for the depth limits. If they try to move down, okay, if they try to move forward actually, then it's going to move backwards. If it tries to leave backwards, then it's going to move forwards. So to do this, we are going to need a variable to help us. So here in the bouncing enemy, we're going to type private vector3 target velocity. And the trick that we're going to do here is the following. In the update method, we make the player move according to the angle that we used it for it to start. Right now it's set to 90, but if we set to 45, for example, it's going to move diagonally. But we want the angle in this case to be used as some sort of kickstart. So this is going to be the angle that is going to be used by the bouncing enemy, and well, all of the other changes of the velocity are going to be done if the enemy collides with the bounce of this scene. We're going to grab this block of code here, and we're going to cut it from this place, and we're going to paste here in the start method. Okay, so we're going to paste this here, and I'm going to add here a initial velocity. But the thing that we want to do here is, instead of hard setting the velocity, we want to set the target velocity variable that we're doing here. So I'm going to type target velocity equals to that value here. And in the update method, we're going to type get component, then we get the rigid body, then we type dot velocity equals to target velocity. So if we save this and we take a look at Unity, we're going to see that nothing special would really change. Okay, we would still move into a certain direction like this. Okay, it's moving diagonally. But now we can use this target velocity and change it in these checks that we did here. Okay, so if we are moving left and we are in the leftmost horizontal limit, then we're going to change the velocity in the vertical axis. So we're going to type target velocity equals to a new vector3, and we need to pass x, y, and z. X is going to be minus target velocity dot x, y is target velocity dot y, we don't need to change the sign here, and z is target velocity dot z. Okay, that's pretty much what we need to flip the horizontal velocity. And even though when we are here it's going to flip the moving left value, we're going to use the same logic for the target velocity. We're going to flip the sign. Okay, it doesn't matter if it's positive or negative. We could infer if it's positive or negative, but we can pretty much use the same line. Okay, if it's a negative value, it becomes positive. If it's positive, it becomes negative. We do the same thing for the moving up portion. I'm going to type target velocity equals to new vector3, then target velocity dot x, target velocity dot y, and minus target velocity dot z. Now we can copy this and paste here to save some time, and it's pretty much do the same thing. Okay, so with this in mind, we're going to basically flip the target velocity. It doesn't matter where it hit. So we're going to save this. Let's wait for Unity to compile, and after that is done, let's press the play button. Okay, so we have our enemy in this place. It's still moving into that direction, so let's see what we need to do here. So, depending on how quickly the game is going to process where the bouncing enemy is, to avoid any issues, we should hard set its position, okay, just like we did with the rolling enemy. So if we try to leave from a certain bound, okay, we're going to force its position to be where it should, okay, not exactly like the rolling enemy, but as the player, for example. So here we're going to type transform.position equals to a new vector3. X is going to be minus horizontal range, in this case y is transform.position.y, and z is transform.position.z. We're going to copy this line from this portion of code, and we're going to paste it here, but instead of minus horizontal range, we're going to use positive horizontal range. Okay, so we make sure that the bouncing enemy is going to move back to the exact limit where it should be. We do the same thing for the depth axis. So transform.position equals to a new vector3. X is transform.position.x, transform.position.y, and for z we use depth range. In this case, let's copy this line and we're going to paste here, in this case, Okay, and one thing that I've noticed here is we're checking here if we are moving up and the Z position is greater than depth range. Okay, and in this case I'm checking if it's lesser than depth range. In this case it's lesser than minus depth range. Okay, so it's moved to a negative place. And now we put here minus depth range. Okay, pretty much the same logic as we did with the horizontal range as well. So let's try that out. Okay, I'm going to save this. Let's go to Unity. Let's give this one more try. So we wait for the compilation to be complete. Now we press the play button and we have our enemy moving like this. Okay, we're going to change this angle later. So it basically bounced from where it was, okay, from the top area and the right area, and it's going to keep bouncing like this. Okay, not a good starting angle, but we're going to adjust this. Okay, we can see that it's flipping as expected on all necessary axes. So now, to make this test a bit more fair, let's change the angle from 45 to 75. Okay, let's save this, wait a little bit more, and after this is done, we're going to press play. Okay, so there we go, and it's moving like this. Okay, it's much better, but we still see that the flipping is not working completely correctly here. Okay, if it moves up, it's not well, flipping back to where it should be. So we're going to check this out too. So one of the issues that we're having here is related to the angle that we're using, and what is the velocity that if we are moving left or if we are moving up. Okay, because the angle is already defining where we are moving to, so we need to redo a little bit of this system. Okay, we need to better define how the angle is going to be set and how we're going to define if we are supposed to be moving left or not, if we're moving left or right, or if we're going to move up or down. So in the next video we're going to redo this system so we have some random angles to be used, and we should be able to finish and complete this issue.